Live from New York, it's Asking Engineers.
Hey everybody, welcome to our kind of semi-official 4th annual show.
That's right.
We've been doing this show for how long?
4 years.
If only we had a logo.
We do. Look at this. Ask an
Yeah.
Engineer. 4 years. We have these animated GIFs, but they come in all glitchy. Look at this. Ding, 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 ding. They come in too fast.
That's kind of cool.
Yeah, look at this one. Poor Adabot. Okay.
Cool.
But,
I like that one.
It's very hyper.
Okay.
Introduce yourself, Lady Ada.
Okay, yeah. I'm Lady Ada. I've been the engineer on this show for 4 years. On this episode, we also have guest engineer Amanda, the Wozniak, no relation, who is totally awesome and is the analog to my digital, my
So
The
nice.
PFET to your NFET?
my N channel to my P channel, my high side to my low side.
Current source to current sync.
Yeah. My Thevenin to my
Norton equivalent.
Anyway, we've got an exciting show today.
Yeah. You guys are punchy. Okay.
Okay.
All right. On tonight's show, we will be celebrating 4 years of Ask an Engineer. The code is 4 years. 14% off everything in stock. That's probably a bad idea, but we're doing it anyways. We'll talk about what was on the show and tell. We'll have Pack in the Mailbag. Reading some letters from customers. Open source hardware news. News from the Adafruit learning system, tutorials, guides, and more. Almost 300 tutorials now. Wearable Wednesday. 3D Thursday. Pi Day. We'll have new products. There's a little sound. Yeah. We'll answer your questions. We'll have a trivia question. And we'll show a picture of MOSFET at the end. All that and more on Ask an Engineer.
That's us. As ears.
Yeah.
Ask engineers.
Okay, so let's first pay some bills. 4 years is the code. That is
4 more years.
That is 14% off everything in stock. This code expires at midnight. So
Tonight.
11:59 tonight, August 24th. Please buy 4% more stuff. I don't know.
It's well, I mean, we have an
Yeah.
anniversary, so we want to make it more exciting. Yeah, this is
Always fresh, never frozen. Don't delay, buy today.
Yeah.
yeah.
So that's it. And the reason we're doing this, and we'll talk about it in a couple minutes, is Ask an Engineer has been going on for 4 years. So if it was Saturday night for the last 4 years, you know where we've been. And
Yeah.
Woz is joining us. Woz has been the most frequent guest on the show.
I'm glad that Woz is on the show now, because actually I'm recovering from a cold a little bit, and I've
Yeah.
been a little sick. But it's really good because I've got to catch up on Netflix a lot.
Yeah.
And I have a new favorite show.
What's that?
It's called Breakout Bad.
Breakout
I don't know if
Bad?
you've heard of it.
Yeah.
It's this chick who like dyes her hair pink and she makes these blue circuit boards, and they kind of take over. And
Yeah.
I've been really sick.
Breakout Bad?
Yeah.
Breakout bad.
Okay.
A non-standard
I heard
business
it's almost
all
as
the
good as
time.
The Wire.
Or
I
Transformers.
was totally set
Oh
up
yeah,
for that.
don't forget Transformers. It's the new blockbuster of the season.
Yeah.
Yeah.
All right.
High tension.
Okay, so
bipolar is
let's,
the new
let's
block.
jump right
Okay.
in.
All right.
We just had the show and tell, awesome show and tell, worldwide show and tell. There's people from around the world. Lady Ada and Woz, what was on the show and tell?
Okay, we had an exciting show. I kind of just want to jump to the payphone, but I can't. We have to
Okay.
start with John W., who came back. He's actually been on the show a couple times,
Yeah.
and he makes his own watches. And he had this watch which was made with an OLED and has like a battery backup. And
And
it's pretty intense.
he was spending like a lot of time on all the different UI features.
Yeah.
You know, he like really thinks about the power up state, the power down state, when it's fully charged, when it's still charging.
Yeah,
It's really
So
detail
it's like a process. I kind of like watching this watch over the last
Evolve.
couple of weeks. Yeah. Next up, we had Elizabeth show up. She had a wearable project. She made like a hoodie, which was this black hoodie, but with like this NeoPixel diffusion in the collar, which is kind of nice.
Yeah, and then she had a clutch where she was using a special type of acrylic to do edge-lit LED diffusion. So you
yeah.
have this like really pretty like edge-lit panel that had a lot more light density than you normally see from
It's
an edge-lit
actually what you
acrylic.
see in signage. It's
Yeah.
used in signage a lot. They edge light it, so it doesn't.
It really fills the space.
It fills the space.
But in a clutch form factor, it's very nice.
Yeah, and she's like working on thing it. And then John showed up with a tablet holders.
Holders, plural, too.
He's got like some pretty cool skills. He built like a metal tablet holder on a tripod, and then like a one for like sitting on his very nice
Yeah, that he
easy
put together
chair.
out of cardboard and paper.
Yeah, that was really and it had
really
a little
solid.
thingy holder.
It had like really nice alignment brackets. So
Yeah, that was pretty sweet. I liked how it was like I was like, is that made out of like a CD-ROM? He's like, it's made out of CD-ROMs, and I'm like, yeah.
hard drive cards.
Peter showed up. Peter had the coolest projects, I think, because I just love payphones. He had an intercom made out of payphone. And he's actually right. It's actually cheaper to get a payphone and mod it into a phone than to get an intercom phone. Because you can get a payphone for like $100.
Yeah.
And the payphones are like battle tested. You can abuse them.
You cannot do a thing to these.
Yeah.
And also it's cool because it's like nobody expects
And then
a payphone.
He was using something different from Asterix.
Free switch. He said it's
Free
taken
switch.
over.
I gotta check this shit out. Yeah, Free Switch, which is kind of cool. And then he made a project for his grandmother.
He basically did a homespun first alert. So rather than like, grandma has the button that she hits in case she falls, like you see in all the cheesy commercials.
Yeah.
She has a button that she hits that goes to a
free switch box.
A free switch box
And
that
it calls.
calls her daughter to
Yeah.
be like, grandma needs help, which is perfect.
And it said like, grandmother needs help. Come quickly.
Grandma needs help.
Alert. And I was
Grandma
like,
needs
this is
help.
cool.
Yeah.
So actually, I like that project. I actually want to maybe have that project as a tutorial because it's a cool project. And then Chinmay showed up, and he's working on this GSM module that he's actually programming the GSM module itself, which is actually kind of interesting because, all of these, it's like I've noticed with like Bluetooth, for example, there's a processor inside that you can program. You don't actually need another microcontroller. You can actually do everything you want usually on the module, but you just have to get the compiler.
Right, and you have
that's
to be
the
willing
fight.
to mod the firmware.
Yeah, and you have to
everything else.
get the firmware code. So that's a bit of a struggle, but yeah.
Yeah. All right. Everybody who's on the show and tell gets an As Seen on the show and tell sticker to put on
Just
their
like that.
numerous projects.
Oh, hey.
It's there.
Yeah.
It's just like that.
Not physically, but virtually.
Lady-
Virtually there.
How do people get on the show and tell?
Getting on the show and tell is super fun and easy, and all your friends are doing it. Go to plus.google.com/+Adafruit and find the thread where we say, hey, come in here to get added to our show and tell circle.
Yeah.
And get added to the show and tell circle, and then every week at 9:30 p.m. Eastern time, you can show up and show off your payphone project.
Yeah. A new thing that was in the show and tell, and we couldn't see it from our side, but there's this beta program that Google added us to. And what we didn't see while we were doing the live broadcast is people can ask questions live.
Yeah, and they float.
And they float, and I was able to watch it at the same time. So I think we need 2 computers to do
It's
this.
totally beta.
It's super beta, but it's kind of neat. So people are asking questions. Eventually, I believe that'll be synced up so we can see them while we're doing it live. But it was pretty neat.
Yeah.
So that was cool.
It's a nice augmented UI.
Yeah. It
works.
Well,
And it works.
Yeah, the way it works too is you can go through each one, and as you're answering the question, on the screen for everybody else, it'll show the question and the person.
Yeah,
Kinda
they're
neat.
working. They're working on all these. There's all these Hangout add-ons, these little widgets, and
Yeah.
they're working on it.
Okay. As we said before, we're celebrating 4 years of Ask an Engineer. So
Go with the animated GIF again.
Yeah, that was actually, I really like it.
The second
This
one.
one?
Yeah. Bam, 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 bam.
People spend a lot of time actually trying to get visual effects like that.
Yeah.
Like, that is
That's
really
the-
it.
Well, when I bring it into this application, the animated GIF, this is what it does. I really like it. So here's a couple screenshots. This is when we first started doing the show. We did it on a shipping computer that was attached to a free webcam that we got.
Yeah.
And the way
I
this
still think we're using the free web. I think these are still the free webcams.
These
Oh
are-
no, we got these later.
we did buy these. These are Logitech HD cams. We also have our soundboard now. We all have
Wow.
mics, and we have nice lighting.
It's
we have all these
incredible.
things. But the one of the reasons we started the show was you were doing the kidding, I was doing the shipping, and
We were a team.
Yeah, and it was just us. And customers would watch the chat, and they would say. Or maybe they weren't customers yet. They would say, "If I place an order right now, will you ship it?" And I said, "Sure." and
we did.
And then some of them we called the show, Ask an Engineer, and they would ask engineering questions while we would listen to Morrissey and The Cure and other fun, dark, depressing music.
Like you do.
Yeah, like we do.
Yeah, all the time.
And it turned out it was a hit. People really liked it because it's not really scalable to ship Lemoore around the world to answer engineering questions.
I'm heavy.
But everyone can. But everyone can participate online. So we started doing that, and it's worked out really well. Thousands and thousands of questions answered. Thousands and thousands of people have watched the show. We've had the A to Z of folks. So from Arduino to SparkFun to
Yep.
Woz.
to Woz.
Woz.
Bree from MakerBot's been on the show. We had the
Bree.
entire Arduino team.
We
Released a
had
big chunk of them.
we had Charles Guan from Miters.
Yeah.
Just a couple
Just
weeks
recently,
ago.
I think we've had Aya from Little
We
Bits.
had Aya on the show.
We've
you
had
had tons of
roboticists, you name it. Everybody I think has come through.
Everyone who we can scam into being on the show, we've got them on the show.
Yeah.
If we could trick them into doing it.
And
Can't always trick them though. Just watch
and
it.
every week we would at the end of the show bring MOSFET the cat up, and if we had a LED product or project, we would stick it on him.
Put on the cat.
And
He hated it.
no one called authorities, so that's kind of nice.
Yeah.
He's still
we
with
totally
us.
got away with that.
Yeah. And so here is a little look back, and then I'll just zoom in on this photo here, and here we are. You can see a little snapshot in time. If you're a time traveler and you want to say hi to us, you can always go back in time and know where we're at on a Saturday night at 10 p.m. We've recently added the show and tell as a new thing. And then on Wednesdays now at 2 p.m.
It's been 2 years.
Yeah.
Yeah.
It's been going on for a while.
Yeah. Time's flying by. It seems just like yesterday. And then we recently added Wearable Electronics with Becky Stern on Wednesdays at 2. And we're probably going to add a couple more shows.
Ooh.
Yeah, so that's coming up. And then
I'm like the Oprah of electronics in my
Yeah.
own network and cable.
and
It's where I'm going to have this breakout bad show.
I actually think that there's Madonna, there's Oprah, there's Martha, there's Lady Ada. I think you're a contender.
Okay.
But the
I can make pies.
yeah, raspberry pies.
Okay.
And so it's neat. It's a cool thing that we started, and we're going to try to keep this up as long as we can. We are going to move this show probably to Wednesday nights starting in October. We want to have like the show lineup for the day, so we're going to do that. Also, we can get more people in because Saturday nights at 10 is kind of rough.
It's true. It's true.
All right, so let's just dive in.
Okay.
Some big news in the world of Adafruit. Adafruit is now an Inc. 505,000 company. Adafruit is number 26 in the top manufacturing companies for fastest growing companies. Number 76 in top 100 New York companies. Number 92 in the New York City metro area. Overall, 1,119.
Is the first one New York State? Must be New York State.
No. The first one is the fastest growing out of all the manufacturing companies that are in this list. We're number 26 in the USA.
And the next one is New York State and then New York City.
Yeah.
Okay.
So we're now listed. It's one of those things where companies like to see recognition. You have to be fastest growing. So since
It's a percentage growth.
yeah, so since last year we and the year before we've tripled. So that's
that's
over,
not even counted
That's
here.
over like 200%.
This was 275% over 2 years. So next year we'll probably be able to even go up higher in the ranks because we grew so much this year.
We grew more, yeah.
Yeah.
Yeah, I'm
Thanks
always
to our
astounded
lovely
every
new
time.
factory.
Yeah.
Every time I come.
Yeah, and if you look at just historically, in 2009, we were lucky to get a couple thousand orders in a month. We do that sometimes in like a day or so now, and tens of thousands of orders a month now.
Yeah, we now have like 15,000 orders?
There's a lot, yeah,
15,000
and it's
orders?
just going up and up and up. So thank you everyone out there because we're here because of all of you. So speaking of, here's Packet the Mailbag. Have you seen this animation?
Yeah,
of this?
no, Packet's adorable.
Cute.
All right, Packet the Mailbag. We're going to read a quick one. This is from Aaron. Aaron says, I just want to tell you how thrilled I am with my purchases on your site. The product quality is excellent. Tutorials and guides are second to none. I'm having so much fun with my Arduino, Raspberry Pis, and the accessories I purchased for you. Please keep up the good work. I haven't had this much fun since Legos as a child. Well, thank you so much, Aaron. All right.
The plural of Lego is Lego.
Yeah. Yeah.
Just had to get that out there.
Should be capitalized.
I want to be that guy.
Yeah. Be that guy. All right. John Janier, who's our director of imaging and also a man-gineer, he's an engineer who happens to be a guy.
So rare these days.
Yeah. Lady Ada, you had us. He made this GIF, and you thought this was really cool. What is this?
What is this, Waz?
It's a scope. You've got a couple of. Oh, really? Oh, nice.
Yeah, it's because
Yeah.
What is this?
It's,
What is that?
Well, it looks like a phase lock loop. So you've got an input, and it looks like you have a locked output. You've got some jitter, and then it locks in. And I don't know why it's switching between these two duty cycles, though.
It's starting. It's watching it. You're watching it lock.
Oh, okay.
So it's repeat. It's like
Why is
like
it
the vine.
Why is it going between the two
Because
different?
it's a vine. It repeats.
Okay.
Yeah, that's the new thing these days. All the kids are doing it.
Really?
So you can watch it lock repeatedly
Just ad infinitum.
forever.
It never ends. It
Yeah.
never stops being interesting.
Face lock loops are cool.
They really are. You need them anytime you want to do any sort of digital TV or actually like any communications media. You have to understand PLLs.
Yeah.
It's my favorite
The
station.
backbone of radio. It really is.
All right, next up, from the Adafruit jobs board, the jobs board that anyone can post to, but it has to be a maker job, and we approve them. You can post up your skills, or you can, if you're a company, post up who you're looking for. Little Bits is looking for assembly and prototyping freelance engineer in New York City. Little Bits is a very cool company run by Aya. And,
Open source hardware?
Open source hardware company. And speaking of, it's some news in the world of open source. So, Open Hardware Summit
Yes.
coming up soon in, let's see, just 2 weeks.
Just under 2 weeks.
Just under 2
Oh,
weeks. And,
so soon.
And Waz, you are giving a talk.
Yes, I am.
What is your talk about?
So my talk is, I think it's called Collective Innovation, Enjoy the Mess. And the basic idea is it's extending on my previous two talks about documentation and then sort of engineering design process and good practices. It's extending that towards project management. So what does it look like if you're actually following the open source hardware documentation best practices? So rather than being like, document stuff, let's do a walkthrough, and let's do a walkthrough and a sample project management framework.
Yeah.
Because managing data between a team of engineers is hard, and everyone does it differently. So I'm going to be going through like a lot of different ways that you can try to manage your projects, but at the end of the day, the whole goal is to have something cohesive, have your design files, have some meta documentation about why you built it that way, and coordinate communication. It doesn't matter if it's email, Google Docs, a PLM system, but
Yeah.
so it's going to be a good introduction to that, hopefully.
And what time do you know your talk time?
My talk is in the afternoon, in I think the fourth session, and the Open Hardware Summit this year is hosted at MIT in Kresge Auditorium,
Kresge.
co-sponsored by Miters, which is super exciting.
We are also a sponsor.
Yeah.
Adafruit gave money to the Open Hardware Summit, and we're also members of the Open Source Hardware Association. We've given money to both of those. So if you're interested in supporting, if you can attend, go to the website and help them out. There's still tickets available.
There are, and everything's up at the OSHWA website.
Yeah.
Please go check it out.
All right. Next up, Adafruit Learning System. We have a couple new. A couple new things. Lady Ada, what is this?
Oh, we just posted this up. Oh, you're fast. This is a new mini tutorial on our analog feedback servos. We've added these lovely servos that have a special fourth wire. The fourth wire is a feedback from the potentiometer inside, which allows you to do stuff like checking what position your servo's at. Also allows you to do recording or use a servo as an input. It's just kind of cool. Check it out. This is a little discussion of what an analog feedback servo is, because it's kind of unusual.
Have you ever played around with these ones?
I actually haven't, but
You can't get them. You usually make them.
Servos, yeah, it's true. Like normally you'll add something to a servo to record the position.
Yeah.
It's funny you mentioned recording. That's actually a feature in Kurt Vonnegut's Player Piano of like you drive an armature with a motor and it records the motion and then plays it back, right?
Yeah,
so
that's exactly
what this is. It's recording the shaft position via a potentiometer.
Yeah, so you can do that, but it's cool because you don't need anything extra. I just had this factory soldering extra. It's a little more expensive because they have to solder in this wire and they bring it out, but
Yeah.
Yeah,
I think it's
normally you would add on a shaft encoder of some sort.
Yeah,
but then you
fuck
have to like
that.
make it yourself, and
and then it's
there's
what if
an
it
art
comes
to it.
loose?
Yeah, it
No
has to be
good.
glued on appropriately.
Okay. Next up, this is an updated tutorial. What's going on here?
We've updated this tutorial to add in the ADXL 377, which is a plus minus 200G accelerometer. It's such a unsensitive accelerometer because it has such a wide range that people are like, is it broken? I'm like, no, we actually test them.
Yeah.
Testing them really sucks, by the way, because it's like you have to have a super, super clean power supply to see the variations when you turn it because of gravity, because it's like 1/200th of a volt. It's so small. It's millivolts.
Yeah, the full scale range is so big. It's I mean, something like that is for registering like serious impact.
I don't even know what it's for. All I know is we've sold some. I saw it and I was like, this is so cool. I wanted to carry it.
Is that one of the automotive grade parts?
I think it is. The photo on the analog website is like of a race car and shit. And I'm like,
Yeah.
That's
so
it's for like rocketry. It would be good for rocketry, for like some physics experiments where you want to like collide something into something else and you want to measure the force.
Yep.
You know, most people can't even like
No,
hit something 200G. Or
yeah.
even
There are
30G.
It's
huge.
Yeah, but if you're actually doing anything that's impact based, you'll saturate a normal sensor.
Yeah.
Right.
What's
So
nice
need
is
the
you will
large
not
dynamic range.
saturate this at all. 200G. I don't even understand what goes to 200G.
It's time to break out your physics and like say if I have a hammer and it weighs 5 pounds.
Rockets.
Yeah, I'm saying like
Elon Musk,
it's
perhaps you could
different.
No, but I
Elon.
mean in normal usage, because a lot of people like to use accelerometers to do position and tilt detection, and
Yeah.
this is not for you unless you're very good at doing good amplification.
Yeah, and
noise
it's an
reduction.
analog MEMS sensor, so you need an A to D. But that's actually most digital sensors actually just have the A to D inside.
Yep.
So this is like raw output, which is really sweet. Anyways, it's a cool sensor. Check it out.
Okay.
We'll show it off right now.
Next up, Wearable Wednesday, all the things in the world of wearable electronics. We do this every single week, including the new show, Wearable Electronics with Becky Stern. This week, we have these really cool shoes, and we have a video.
Here's an easy project to put some spring in your step. Use LED ribbon from Adafruit to adorn any pair of shoes. Start by stitching the battery pack in a safe place. These ballet flats from Adidas take the battery packs under their wings.
Use E6000 or a similar glue to affix the ribbon around the edges.
And we used painter's tape to hold everything in place while it dries.
If your shoe doesn't use a whole spool of LED ribbon, it's simple to connect another battery pack to what's left over. Just slide open the case and remove the white button.
You'll notice the ribbon has exposed contacts every inch or so. Trim your ribbon so one set of contacts is very close to the end. Lift the little lever and insert the raw end of the ribbon underneath it so it lines up with the electrical contacts inside. It will only work one way, with the LEDs facing away from the control switch.
But you can't damage it by plugging it in backwards. So if it doesn't work the first time, try flipping it over.
Try your wings at this project and see if the shoe fits. Once you've got your foot in the door of wearable electronics, you may be hooked. Subscribe to the Adafruit channel on YouTube and don't miss our weekly live show about wearable electronics with me, Becky Stern.
Okay, and that's our Wearable Wednesday.
I like that project. It's easy.
Yeah.
It's simple.
Yeah, we have a
no
lot of cool-
microcontroller. Sometimes we go crazy with the microcontroller. Sometimes we're like less microcontrollers.
Yeah, we have a lot of cool projects ahead. Folks always ask about some of our future products. Trinket is coming out, which is very small.
Trinket's coming out. I got the PCBs. I have to build a tester.
Yeah.
And this is unfortunately a little tough for as testers go. So
And
it's good
Gemma
to Gemma
is the next one.
PCBs got delayed, but they are being made right now. Hopefully, we'll be on our way in a week.
So Trinket is kind of like a really, really tiny Arduino, just to give an analogy.
And Gemma is a tiny
Flora. Yeah. When folks saw Flora, they were like, wow, this is really small. This is great. It does all this stuff. I can finally get into wearable electronics and do all these sensor things. And we're like, okay, let's immediately make something better and smaller. So, well, it doesn't do everything that Flora does, but it does a lot.
It only has 3 pins, but it can drive NeoPixels. It can do analog inputs. It can do PWM outputs. For some projects, if you just want like a button and then some pixels, because a lot of people are just like, well, I just want to make like a necklace or jewelry.
It doesn't take much to actually add a lot of really sort of beautiful light effects.
Yeah.
When I was a kid, we only had 3 GPIOs. And they were open drain
And we loved
and
it.
open source, so you can use them all.
And you had to walk 10 miles in the snow to get to
Look,
get to the,
you were lucky if you actually had a controlled value resistor.
Yeah.
Normally they didn't even have color codes anymore. You just had to dig through the box and
You just
hope
had
you
to
got
taste
lucky.
it.
And all the
then
pins
they
you got were hand-me-downs from your siblings.
I
Okay.
know.
Next up,
Those are the days.
3D
I
Thursday.
don't know how lucky you guys have it these days.
Every Thursday, the best place online to learn about everything in the world of 3D. So I picked, I got 2 things. I'm going to quickly just mention one, and then I'm going to talk to Woz about the next one. So the MakerBot Digitizer was announced, released, seen. You can get it now, and I think it ships in October. It is a little 3D scanner. So,
Oh, okay.
yeah. So that's out. We're probably going to have these in our store soon. Probably next week we'll have the ability to purchase them or at least sign up for them.
Yeah,
And
we hope to carry them.
yeah, you put a little object on there, scan it in, and then you can print it out.
It uses the camera plus laser
Yeah.
technique, where
Just
you
like
know,
the David Laser scanner.
Yeah.
There are a lot of projects.
there's a
like
lot
that,
of
actually.
projects like this,
Yeah.
but this is a very nice all-in-one, ready to go, easy to use, and it has software and everything.
I was going to ask, what format does it spit the files out
I think
in?
it's STL or
It has
something.
to be STL because it's a MakerBot. Yeah. All right. Next up. So these are all sorts of 3D printed things in the world of medicine and bio.
Yes.
And there's a lot of discussion about this. Here's the news story we posted. Here's a 3D printed ear out of materials. Woz, since you do this for a living, what is possible with 3D printing organs? Is that going to happen in our lives?
Yeah, so like a lot of different people, and I see it all the time, are doing tons of research on stuff like 3D printing cells, or 3D printing protein scaffolds, or 3D printing things like, I think even at last year's Open Hardware Summit, someone presented they were 3D printing with sugar and using that, and then putting that in sort of like an agarose gel, and then dissolving the sugar and flowing in cells to make complicated capillary structures. So 3D printing is used in bioresearch all the time. You use it for like Invisalign, for dental implants, for cochlear stuff. Anytime you need to make sort of like a custom, or it's used in custom orthopedics already, right? Like someone will actually 3D print a hip attachment in like selective laser sintered metal. That's very, very common.
Okay.
What people are thinking of as the future for 3D printing is trying to actually make replacement organs, which is promising as long as people remember.
Livers.
Like livers,
Which are not
kidneys,
structural
blood.
as much, right?
Well, so that's the thing is, at a tissue level, there's an interplay between cells and how the cells function in their mechanical structure. And so for tissue engineering, that's one of the huge fields of research right now is understanding, yeah, you can like make a protein matrix, you can put cells on it, but how do you get them to act like the organ? And a lot of that has to do with how well can you control the structure you're building, and have that actually interact with the cells. So better biocompatible materials. But there's really awesome stuff like some researchers at MIT were printing a differential structure on an object with 2 different material types that acts like bone, right? So like people are getting really good at reproducing the mechanical function of tissue, and people are really good at manipulating cells. And I think in the future, like there will be a lot of work to combine the 2. Problem is you have to make it cell compatible, right? Like cells are, it's really easy to contaminate a tissue culture setup. Cells are finicky. But that's the goal.
Could they like 3D print something that's cell friendly, and then like
so like
steam it or whatever to clean it out, and then you can
seed it. So there are a lot of people that are actually working on.
I'm assuming there's like something like turkey baster or like something.
Yeah. So what it is if you can
Basting.
print. If rather than printing with like an ABS plastic, right, you print with a bioresorbable, the whole class of polymers is referred to as bioresorbable or bioabsorbable. And the idea, it's protein that you would normally see in tissue. So if you can extrude collagen or elastin or any of the other different sort of matrix proteins and control a structure with that, have it either sterile off the bat, some way to sterilize it, and seed it with cells. Cells love to stick to proteins. They'll stick to all sorts of stuff.
Okay.
And so that's the basis of, I think Tufts was working on 3D printing some organs. Tons of people are doing it. Everyone's like, we have the 3D cell printer of the future. We're going to go, steak someday.
So you
It's
do
very
this.
cool stuff.
I mean, this is what you think about and kind of do for
Steak.
a living, right? Like you're in that world. You work at a.
Yeah, I see. I mean, you see tons of research like this going on in the hospitals all over Boston. Like all of, you see it. I'll go to a medical device conference and everyone will be talking about how are we going to engineer someone's replacement organ of the future. And they're thinking about not only how do we do the cell biology, but how do we make the equipment? How do we make a 3D printer that can actually, rather than printing millimeter scale structures, print something at the nanoscale.
Yeah.
And do it quickly, like quick enough that you could actually like take a tissue sample and have it ready in the course of a 5-hour surgery.
How far out do you think we are of this stuff actually being used quite a bit?
I think that it's not as far as you think. So a lot of, at least for me as an engineer, like going through and reading like +1 and bio and cell papers.
Well, we're using it so much in dentistry already.
Right. So the tools are there and the industry is there. A lot of it is figuring out the open scientific questions of how do you make tissue work, right? Like that's where all the tissue engineering research is how do you make, like everyone's like, oh, we 3D printed an esophagus or we 3D printed someone's trachea, right? And it's a good mechanical substitute. But how do you actually get it to act like someone's tissue? Like how do you make an organ that's not just a mechanical organ, but is actually like functionally replacement tissue? And that has to do with like the cell and the biowork. But people are putting out amazing papers all the time. Like you could actually, and honestly, I'm always amazed that biologists and lab techs can do this, but actually figure out how cells are communicating with one another. Like, oh, this cell puts down a protein and this other cell interacts with that protein. Like people are actually answering those questions. And that's the only thing that stands in the way of, what's the engineering problem I need to solve to be able to print a bladder or print skin grafts or things like that.
Yeah, printing skin, that'd be cool.
Printing skin would actually probably be the most useful thing ever.
Yeah.
So
Like-
burn victims and things like that.
Yeah, the best innovation that I've
Something
seen to
neutral
date.
enough that your skin would absorb it
Yeah,
and
the idea
join with it.
the idea is that you make something that eventually your body either accepts as a replacement or replaces itself. And what the leading edge for burn treatment is to take stem cells and actually like airbrush it onto an open wound and then hope they graft rather than taking skin stretching it, taking it from somewhere else in the body and sticking it on. It's like, well, how can we just get it to grow in place? And a lot of that is how do you get cells to start acting like proliferating tissue, like new tissue?
Okay, a related
cool
question.
stuff.
So you're
Dubstep.
you're an electrical engineer like Lamore. You both went to school together, but you've decided to devote your time to doing, bio stuff.
Yeah, medical. And
Yeah,
biomed.
medical. So you've made a leap from circuits to, blood vessels and stuff like that.
Yeah.
What was the reason for you to decide to pursue that?
The reason was there were some, I was looking for additional classes to take, and I've always loved bio, right? But bio always seemed like it was storytelling. Like, oh, we have this theory of how stuff works and it changes every 5 years. But there were some classes at MIT that were actually in the Course 6 major in electrical engineering that were hybrid biomed classes, like use electrical systems theory to model how nerves work, like action, potential, conduction, and how cells are, like how cell electrical signaling is mediated. And there was another class, quantitative physiology 2, which was let's use circuit analogies to explain function of the cardiovascular system, because it is the same thing, and you can actually explain.
And that was the Sussman class.
No, that was Roger Mark. That was in health sciences and technology. So it turns out there's this, bioengineering is an amazing discipline, and you use all of the same engineering principles of feedback and controls, circuit analysis, understanding the relationship in, basically differential systems, right? It's true for mechanical engineering, electrical engineering. It's also true for physiology. It's fantastic. So I started just taking those classes, and then a friend asked, "Oh, you're getting the minor?" And I'm like, "Wait, what?" They're like, "Oh, you can get like a degree in this." And I'm like, "Oh, wow." So then I just ended up fleshing it out with additional bio classes, and it was awesome.
That's
There's
really cool.
definitely, even like we took, wait, you didn't take that class with me, but then cochlear implants.
Yeah.
There's a lot of like really cool interplay between, because the body is an electrical system.
Yeah.
Right? Our brain has a voltage potential across neurons that you can measure and then also add. So it's like you can integrate circuitry into the body. It's not actually that hard.
No,
we've been doing it for quite a while.
It's just like with EKG, right? Like if you want to be able to build an EKG machine, you have to understand, oh, your heart is a dipole. Okay, well, what's the field theory for understanding what's going on with the dipole moment of your heart if you're measuring the potential at the skin, right? Solve those differential equations. These are standard engineering problems that you have to solve, and it's just like, okay, if you wanted to reconstruct what's going on with someone's heart, but you only have so many leads, how with like 5 data points instead of 20, do you accurately reconstruct a vector cardiogram? Do you know what your error is, right? So this all goes into how do you make something that interfaces with the human system, because we're not just chemical machines, we're electrical machines. Like that's how muscles work, it's how nerves and cognition works, it's how your heart works. And just being able to integrate a sensor with physiology is super important. And for that you have to understand both how the physiology works and you have to understand how the sensor works.
Yeah.
So you have to have both to bring them together.
Qualified for this. Yeah.
But there are tons of biomed engineering programs out there, and a lot of like the best biomed engineering program will actually have you take fundamental electrical or mechanical engineering classes, and then the bio and the physiology too, and bring them together.
I don't believe that a bio student who takes EE classes could conceptualize this stuff as easily as an EE
who takes bio classes.
I am a little bit biased because I think.
No, I agree. I think the right thing to do
actually
is
electrical engineering is difficult to conceptualize than biology. I think you actually like we didn't even you don't even understand what a transistor is until like 3rd year of EE at MIT. It actually takes you 3 years before you're like, oh, I think I understand how a transistor works.
Or 4th year to understand all of the field equations that go into why a capacitor is a capacitor.
Like how does a diode actually work? You don't understand until your 4th year, which kind of sucks.
Yeah.
But and I didn't even do well in that class either. So like, it turns out it didn't quite work out for me. But it's actually quite difficult.
It is
to understand how like a voltage potential works in 3D space, like in a heart.
Yeah, and so that's why I'm a fan of and I get to work with tons of amazing biomed engineers from the undergraduate level up, and I'm always a fan of ones where their degree program has them start with engineering classes, and has them learn all the different math and all the different analysis methods, and then layers all of the bio and applications onto that. There are some programs that I'm not a fan of where everyone sort of immediately jumps into multidisciplinary courses, but then they don't seem to get, I would go nuts in that sort of course format because I wouldn't feel like I was understanding enough of all the different parts.
And then one last question. and I know the answer, but I thought it would be nice for you to say. So, do you use tools like Arduino and
I do.
and coding in like Python?
Python is on my list of things I desperately need to learn.
Is it used a lot in these settings?
It is.
So
it
that's
is.
The
So
you were
language of
using
science.
Perl before.
I use Perl and MATLAB
That was used
for
a
most
lot.
things.
But
Yeah.
Arduino is used frequently for
Yes.
all this stuff, for prototyping and just getting
hands
stuff
down,
done?
hands down. Because a lot of times in a biomed challenge, you're figuring out, okay, well, how can I attack the application? And you don't necessarily, even if you are trained as an engineer, you don't want to spend all your time in the low-level details. So you get a sensor, you get an Arduino.
It's like a piezo or
It's-
like a temperature sensor. It's actually not.
Or a servo with position feedback, so you can get joint angle. Tons of people
It's
use
not
pressure
complicated,
sensors.
yeah.
It's not complicated stuff. Building an EKG is not complicated, but if you want to build an EKG with data logging, why not start with Arduino, right?
Yeah, that's like an example.
It's like
project.
an Arduino with an analog front end. That's all you need.
It's an example project for an Arduino that like beginners will do. But if you were going to like try to design that or buy an off-the-shelf product that would do that for you, it's like in the thousands of dollars.
Not only is it in the
And it's
thousands
like
of
you don't
dollars,
need
but
something
it's,
that scale. You just need something basic.
right. And the other thing is, a lot of times, if you wanted to go for a very specific solution, you have to have a very specific skill set even to approach it, right?
Yeah.
Like if you're using if you want to buy like an EKG machine and try to interface with it, you have to learn everything
Like,
about
what if you
what
want to
they
mix?
did.
What do you want to mix an EKG machine with a GPS? Like you're screwed. You can't do
Yeah,
that off
no,
the shelf.
because anything off the shelf is designed for a specific application, and if you're doing your own thing, you want to start with good building blocks to help you. So we use Arduino all the time. I see tons of people using SciPy, right?
Yeah.
Like people use Python for tons of stuff, and you see open source show up constantly in science and in
In
biology.
academia, yeah.
Okay, next up, Pi Day, every Friday. All the news that's fit to Pi. I don't know. I just have one thing. I think some of the folks mentioned in the chat room, but they're putting this bear in space. This is a Raspberry Pi Bear. This is the Pi Bear.
Oh man.
And there's a GPS and
Okay.
at 39,000 feet, I think. And I think it's going on right now, and you can find out about it live
Later, bear.
right now. So
Go
that
Bear.
is, that is the Pi Day stuff. Do check that out. Okay, before we go on to new products, just a real quick thing. The code is 4 years, 14% off everything in stock in Adafruit store.
If you don't buy stuff, we're going to cancel the show.
That is unimaginable discounts.
yeah.
unimaginable.
Why 14?
Well, because
It's
we
like
normally
10
do
plus
10% off, and then we said, well,
It's
it's 4 years, so we'll add
so you add
4.
4 plus 10. It's-
So,
this is the
yeah.
math we were thinking about there.
All right,
I didn't learn about that math until my second year.
it is new product time.
Whoa.
Oh, the
Sorry.
new products are falling all over the place.
Sorry.
All right,
Okay.
All right.
Lady Ada, we're gonna do some switcheroo here.
Okay. Hey, Waz, can you?
Yep.
Those are the demos.
Okay. That's cool.
That
Waz
goes
will
Waz.
help me. That thing always falls over.
Yeah.
It's because it's down here. It's kind of crazy down
All
here.
right, the first new product is flexible solar
Flexi
panel.
solar. Yeah, this
Look
is
at this.
cool.
This is really, really, really neat. And we'll go to the overhead in just a second. We want to check out these cool photos from John Junior.
Yeah.
But no, that can go down there
Okay. Okay.
for it to fall down again in the future.
Okay. Sorry, I was giving myself some
All right.
Okay, so this is
To
it.
the overhead.
So this is a film. It's actually a very thin film solar cell. It's a polycrystalline solar panel, and this is a 1 watt, 6 volt panel, and it's a really high quality panel in this really like durable, weather and waterproof plastic. And then there's these solder points that are exposed on the back. So if you wanted to, you could solder to these very easily, and then you would epoxy it closed, or even some gaff tape would probably be just fine. Or waterproof it, or duct tape would waterproof it. But it's a really nice, outdoor flexible panel. There's this nice edging that you can sew through or staple or whatever. We wanted to carry a flexible solar panel, and unfortunately, flexible solar panels that are good quality are really expensive. But this is what we found, and we thought we'd start with 1 watt, and if it's popular, we'd get higher wattages. But we like it. It's nice.
It's the plastic.
I don't know, but it's whatever plastic that allows the.
Could you puncture it in the clear plastic part and sew it onto something?
Yeah, this as long as you don't sew through the panels itself, you can sew through the plastic, especially the edging. That's what I like about this one, is that it's nicely edged and it's soft. You could sew through it with a fairly strong sewing machine.
Could you flex it a little bit? Does it flex in all directions? I mean, is it a...
Oh yeah, you can flex it this way. I mean, this is...
Yeah, what if you were to like,
Can
can it twist-ish a little bit? Can it...
Yeah, I mean, you can
Okay, all right.
twist
This is a
it.
flexible
It kind of, because of the geometry, it flexes best in this way.
Yeah. And does
And
flexing
you can-
change the output at all? I mean,
No, but you just have to make sure that you have as much of it exposed to sunlight as possible.
Right.
So it doesn't matter what the geometry is as long as you have sunlight exposure.
Yeah, because what matters is the incident angle of the sunlight on the panel, right? So
So
if
as
you have
long
it
as you
curved
can-
around and sun can only hit one side,
you could
it's
you
not
could
going to be as effective.
you could bend it so much that it creases. I wouldn't do that personally.
Yeah, what's the bender you use, do you know? Like for
Six inches?
recommended? Yeah.
This seems like you can kind of tell. You're like, oh, it's not creasing, but this is about. This feels good. You could probably do a little bit more, but this feels like it's not upset.
this is cool. I've not seen these around. I think we're the only ones selling these.
Yeah, this took us a long time to get, but I wanted to get something really good quality. This is beautiful.
Okay. Next up, here are some photos. This is a new case for the Raspberry Pi from our friends at Pi Moroni.
Yeah, the photos are really good on this.
Yeah, let's go to the overhead. It is a wood case.
So
Look
it's
at
a
this
wood
beautiful
case. It's really lovely. It's laser cut and it's got 5 pieces of wood and it smells really good.
Looks like birch ply, maybe.
Yeah, it's some sort of plywood.
It's
I don't
nicely
know.
sealed.
It's very nice. And yeah, and then you can have a GPIO cable come out here and you've got all the ports that you've always wanted.
The ports you come to know
I'm
and
going to
love.
skip back for 1 second because there's a question that came in because there's
Yeah.
always a little bit of a delay. Can you chain the solar panels together in parallel?
Yeah, you can do.
Okay.
It's just like any other solar panel. You might want to use a protection diode for each one.
Okay. Everything
then,
else, check the product page first.
Yeah.
All right.
And then
back to the Pi case.
clear. Yeah, we also have tutorials on solar panels
Yeah.
and stuff. Clear bottom and clear top. It's just like it's the timber Pibo timber.
For
Yeah.
when you're doing your Raspberry Pi fun adventures in Alaska.
I don't know. I like it.
All right.
It's a good aesthetic.
Yeah, it's cute.
Next up, another Pi product. This is the Pi Glow, also from Pi Moroni. What is this thing? Oh, and look, it even fits inside the case if you want.
Yeah.
Oh my gosh. So what is this thing, Lady Ada?
Well, let me get my screwdriver. 1 second. Let me get my screwdriver. You can show that photo for a second. Oh,
Okay.
Can you grab me that bin that you just helped me with?
All right, so I'll continue to
You continue looking
show
at
the
that.
photos of this while Lady Ada gets her screwdriver.
Where's my screwdriver?
guys
Oh, here it
can
is. Okay. So,
Watch the action here as it happens.
yeah,
Live engineering.
live. I thought I could undo it with my fingers, but I can't.
Okay.
So you
oh,
can,
can you get the camera? There you
you can open up the Pibo. It works with any Pibo. I don't know what other cases it works with. It's kind of like designed for a Pibo. But it's from Pi Moroni, and they just got to pick and place in like an oven and stuff.
So is
So
this just
they're,
an After Effects kit for your Raspberry Pi?
It is, yeah. It's like a ground effects kit.
Can you, oh, there you go.
Alienware now has nothing on these guys.
Wow, these are tough to undo.
Tight tolerance.
Yeah, these are, I mean, they're like perfect tolerance. So it's a little plug-in board, and it has a 16-channel PWM driver on it. 1 second. I'm just going to slide this out of the way. So you can plug it in here, and the Pi's not on, so you're just going to have to pretend like it's working. But you can plug it in, and it fits in the Pibo case. And let's see, there you go. And there's all these little LEDs in a nice spiral, and they light up in pretty colors, and they have some scratch code, and they have some Pi wiring code, and they have
That's cool.
I don't know, seriously, they have Python code, wiring code, I think that's some Perl code, maybe some shell code for controlling the I2C PWM driver to make effects. I don't know, I thought it was kind of cute.
That's what this is? This is your LED
Yeah,
driver?
there's a little LED driver here, little black square is an LED driver, and then there's the LED. So each one is
Okay.
individually controllable.
Man, everyone's working with, that looks like an LFCSP. So everyone's doing
Yeah, all
fun
this-
with leadless packages
All
now.
this stuff is a QFN now.
Man,
I hate it.
Okay.
so hard to rework.
Next up, just a quick programming note here for everyone. These are back in stock. This is our NeoPixel rings. These went instantly. We had them for like an hour, and they all sold out, and then we made a bunch more, so those are back in stock. But that is not the only blinky thing I have to talk about. This is the NeoPixel 8x8.
Here, I'll do that.
Thank you. Yeah,
And
this is our
new
latest. We
product.
previewed this actually, and
Yep.
then John Jr. took some great photos of
I have
it.
a little bit of video I want to show.
Okay, show this video.
So pretty.
Okay.
Okay,
The overhead.
You ready for
Let me
this?
see.
This is really crazy.
Oh, it looks
So
nice on the
yeah, it
camera.
looks really
Okay.
good. So this is the 8x8 matrix, and it's got 64 LEDs, and it's actually like really warm from all this work it's doing. And you just have it running the demo. So yeah, each LED is individually addressable, but you only need one wire to control all of them. And they're chained down, and it even works with our Neo Matrix code that we have. And on the back, there's these nice gold tabs. You can I designed this so that if you took multiple ones, you could tile them, and they'll tile dimensionally perfect. Like they'll line up.
Oh, you won't see the seams.
Well, I mean, you'll probably see it, but you won't. It won't be the spacing won't be noticeable. If
Yeah.
that
Cool.
makes sense, right? So
Yeah, you won't have a visual gap around
There
the
won't
board.
be a spacing difference because it's like this is exactly 1/2 of the spacing between these two. So this is as tight pitch as we could get it, and I really like it because it's like you can get an 8x8 RGB matrix, but it won't be nearly as bright. You'd have to
Yeah.
multiplex it. This is only one pin, and it's like ready to go.
How many watts?
This draws, I think this is drawing like an amp or maybe an amp and a half right now. So it can be up to like 10 watts. It's pretty bright. I mean, we have a set brightness setting in the Neo Matrix and NeoPixel library, so you can bring this down a lot. But yeah, it's 24-bit color, super sweet. So yeah, there's these tabs that I designed so that if you tile them, you can solder the tabs to make it more mechanically stable. And then you can chain these, and there's some mounting holes around the edges. So yeah, super bright, 8x8.
Great job. And uses our awesome NeoPixel library.
Yeah. And try
So
to-
good
That's
that
intensely bright.
So good that everyone just uses this library.
This
They love
library
it.
is like so popular. I see it like on Kickstarter. I see it like on other company product pages. It's the best.
Very nice of
Phil
you
B.
to release
Rock
that
it
to the
out.
world. Okay.
Pit your dragon.
Next up, and this next product is also another one that's uniquely Adafruit and something that only Lady Ada and K-Town and our team here can do. This is the CC3000 Internet of Things Arduino Shield by Adafruit. It
Yes.
is a Wi-Fi shield that does all sorts of things.
Under $40.
It's under $40. Compare elsewhere with other Wi-Fi shields. You're looking at $89 or $69. Nope, ours is under $40, and it tweets. We got the library working, and this is a tweet.
This is like
from
the
it.
best thing ever.
So,
So
this is
for like years, people have been like, "Why don't you have a Wi-Fi shield? Why don't you have a Wi-Fi shield?" And I've always said like, I'm not ready. Like nothing is good enough, right? And so finally, we found a module that, man, I really wish we had good lighting here.
Yeah, we're getting another light soon. For
It's
that.
like 4 years. I can't get a light yet.
Yeah.
This is the CC3000 shield that we have based on the CC3000 module, and we have a micro SD socket here, and there's level shifting, and there's a prototyping area and a reset button, and we have an onboard antenna. So this one has the onboard ceramic antenna, which is this little white thing here, which is actually a pretty good antenna. And we might have a version in the future that has a UFL as well. But the antenna works really well, and this is the one that I use. So it's soldered, and I plugged it onto a Mega and actually it worked. I never tested it with a Mega, but it does work with a Mega if you use the ICSP connector. But it's right now we're only kind of being like, hey, it's for Uno use only, and we're working on porting the library. But it's a really good shield, and it works. We have examples for TCP, UDP, grabbing stuff from a web server, setting the time, tweeting via the Twitter API directly.
Yeah.
So you don't need an interfacing website. So yeah, it's all good.
Yeah, Internet of Things.
Yay.
We did it. And this is, kind of an advanced thing, so if you're not ready to dig in, wait for a bit. But every day we're doing more stuff with this, and it's the best and only one out there. It's certainly at this price. And for years everyone said, "Oh, why don't you carry the Wi-Fi shield?" And when the Arduino Wi-Fi shield came out, "Why don't you guys carry it?" It's like, well, it's $89. It's really expensive, and we thought, there's got to be a way to have this so it's under $40, and you worked really hard on it. So congratulations.
Hopefully it's
Lady Ada.
visible. I don't know if you can
Yeah.
see it. Okay.
Yeah, we also have that beautiful photo. Okay, with
The
all
photo's
that,
nice.
that is
That's awesome.
new products. Old song plays in mind. Okay, all right, we're gonna do some speed round questions. We're gonna
These are for Woz.
yeah, we're gonna do the show a couple minutes over because this is 4 years. Start asking your questions. Engineering questions for Woz, engineering question for Lamore. I know anything, I'll answer, but I don't really know anything. Where's the guy?
It's cool.
Guys don't do engineering. All right. There's a UFL footprint on the board. Just solder one and move the cap over. Is that?
You can, but just your warranty will be voided. We don't. We will not fix, repair, or replace a board if you
toast the antenna connection.
Yeah, if you mess up the antenna connection. Because it is 0402.
Real quick.
Ooh.
Don't forget.
Don't lift the pad.
The code is 4 years. That's 14% off everything in stock and Adafruit, including that Wi-Fi shield that we just showed.
Buy now. That's really exciting.
Yeah.
I'm super excited
I think
about
we
that.
Someone wanted to know C's for capacitor. We actually discussed a lot of it today with Woz, so we're getting closer. We're going to be filming soon. Next up.
I like how every week people ask as if it's like that's going to make it faster.
Next up.
Are you done yet?
How should I?
Done yet?
How should I
Are we
start?
there yet? Are we there yet?
How should I start an electronics website to sell my projects? Or, I can answer that one.
That's a you.
Yeah. Sell it on Tindy to start off with.
Yeah. That's what
And then if it takes off, then make your own website. Start by taking PayPal button. And then eventually start to look at all the shopping cart systems. There's like Shopify and a lot of ones that are easy to do.
I have one piece of advice.
Yeah.
Don't take orders you can't fulfill.
Yeah, no back orders.
Yeah, that's right.
Don't do that. That's like a great way to
orders.
cry.
Yeah, we've never done back orders because the expectation is when you place an order, it ships, and that's what we want to do. So we worked on predictive inventory and being able to have everything in stock, and that's what we've tried to do.
Just say no to vaporware.
Next up, when powering LED strips, at what point in the length of the strips do you have to start paying attention to wire gauges of the power and data wires and the length of these wires you use?
Okay, this is
About
pretty.
5 meters.
Yeah, and if you really want to do the math, you can look up the current carrying capacity of the cross-sectional area of a piece of wire. Look at how
5
much,
meters.
or if I rule of thumb, do the math. Yeah,
Or like 100 LEDs.
Yeah.
Every 100 LEDs. You should inject more power.
It takes a surprising amount of current to cause metal migration. Standard D rating is at least 50%.
Yeah.
For a standard American wire gauge. But if you go on Google and Google for wire gauge current carrying capacity, and then go from the cross-sectional area of the wire to whatever the standard PCB trace thickness is, and it's either 1 ounce or 2 ounce copper, you can figure out how wide the trace is, you know the copper thickness, you know the cross-sectional area, and then that tells you the current carrying load. And you know how much current you need based on how many LEDs you have in your strip. So.
All right.
I like how you assume that people are engineers and ask questions.
Yeah. So, are we three of us wearing all black? Yeah, pretty much.
Yeah.
Next up.
That's not a question.
It's not a question. That's
an
an observation.
observation.
Yeah. Next up.
It's like a fortune cookie.
Request for the CC3000 library. Read speeds.
Yeah,
that's a
the
request.
library is not optimized. We've made that pretty clear, but
Yeah.
it works.
If you're a good coder, jump right in. It's open source.
If you're the same person who's been asking us 6 times to upgrade the read speed, nothing's changed in 2
Yeah.
days. I'm still working on functionality.
Yeah, don't use GitHub for request either, folks. I think that's not the great etiquette.
It's okay. We just it doesn't matter.
Yeah.
Right now the library is functional and we're still filling out all the functionality.
Yeah, I see the GitHub stuff fly by, and that's usually when I've seen other
You should do what I do, just ignore it.
I've seen other project maintainers, they just like delete everything.
Yeah.
So, anyways, next up, is it possible to do TCP/IP over Bluetooth on Arduino?
No.
Okay. Is there a good place to learn about flexible circuits like the film-based ones?
I usually learn about flexible circuits by going to the flexible circuit website for vendors like flexiblecircuits.com.
Flexiblecircuits.com.
A lot of different vendors will put information up on things like, here's my flexible circuit. You can, have this bend radius possible, this
I think also
substrate,
taking
etc.
apart like stuff that uses flex circuitry is good.
That's actually my favorite, is to
It's like-
just,
it's
everything has a flex circuit in it.
It's not a skill that's taught. I think it's a skill you kind of observe.
Yeah.
Okay. Next.
Teardowns are so
what's the
awesome.
safest way to sense that a 120-volt rice cooker is on with a Raspberry Pi or Arduino? I'm using a photocell glued to the rice cooker light right now, but I'm curious if there's anything cleaner.
It's actually pretty good.
That's a good idea.
Yeah.
Nice.
Because, if you can
Good.
avoid working with wall power, do. Like, it's not
I
worth
think also
it.
like a temperature sensor.
Yeah.
I mean, that would be easy because if it works, it works.
You can also, it's not necessarily easier than looking at the light, because the light is pretty reliable as long as that wire is attached. You can try looking at putting something around the power line to see if there's current going through, but you've hit on something that's like super simple and very robust.
A photocell's pretty good if
Yeah.
it's really like glued on there.
That's how Random Hall used to do the laundry server. Is like everyone thought we were super clever and like it instrumented the laundry machines, and all Jim really did was put a photo detector glued onto the to the LEDs on the front panel of the washing machines.
Yeah, that was for a long time.
All right. Request for a Minecraft Pi tutorial. There's some out there. There's not a really great one. I had one almost lined up, but the person who was going to do it decided to go do something else, and they were never going to be writing tutorials for this. A little bit of a drag. Next up.
I guess this is sad answers.
Yeah, I know.
This is not the
Woz,
answer
how
you're
did you
looking
learn the
for.
do's and don'ts of the rules of electronics in the medical field?
I'm still learning them, actually. So what I do to learn about medical stuff, given that my professional background was all semiconductors before I started at the VEAS, is I go to professional conferences like the Medical Design and Manufacturing Conference. I read the proceedings of MDDI, which is an online thing that you can get access to. I read people's app notes, and the FDA puts out tons of standards and guidances for everything from required reliability tests to other stuff. So I keep on doing homework, and then
Don't stick it in a human.
Yeah,
That can get you really far.
The other thing is that there are in school there were pretty basic electrical requirements for fundamental patient safety, like leakage current limits and patient current limits. So you can look up those standards. And also the standard has to tell you how to test for it, which tells you a lot more about how it works. So get your job to pay for access to UL.
Okay. Next up, Woz and Lady Ada, are you happy with your accomplishments in the last 4 years?
Yes.
Yes.
Okay, great. Next up, where will Lady
No, I'm
Ada,
too fat.
where will Lady Ada appear in public next? Nowhere. You don't have any public things
have
lined
no
up right
public
now.
speaking
We do a
things.
weekly online show called Ask an Engineer.
You're watching right now.
The internet's a public place, right?
Yeah, I do not have. No, I don't have any speaking gigs lined up right now.
Nope. It's time to let other people get in the spotlight.
Yeah.
And
Woz does though. Woz speaking at the Open Source Hardware
Woz will
Conference,
be at the
which
Open
you should be
Source Hardware.
attending. Get your tickets. Watch Woz afternoon.
All right.
I promise to talk slowly.
That's a
You can talk
lie.
fast. All right. Next up, how would you go about selling a product? Tindy, Kickstarter, Indiegogo. Well, Tindy means it's done and you're shipping. Kickstarter and Indiegogo means you're asking for money and you're making a video and making promises and hopefully it works out. Or it could work out too well.
You can always do a Tindy and then go to Kickstarter. And it's not a bad idea because if it doesn't work out, at least with Tindy, it's only like 10 customers, not like 50,000.
Yeah, with Kickstarter,
Upset
it's risky because people can overfund your project, and congratulations,
actually
now you're
screwed.
on the hook for more. Like if you
And it's
only know how to
actually
make
harder-
50,
It's
and
actually tougher to deal with an overfunded project than
An underfunded.
An underfunded project, which is completely not what people expect. They
Yeah.
expect the more money they get, the easier it will be for them, and that's not
No,
true.
because
it's actually harder.
it's
Scale is hard.
Scale is hard, and if it's underfunded, you can live off ramen for a while if you really want to push the project.
And just do it by hand.
And just do it by hand. But if you have to make too many of something and you weren't expecting it, but you have a
Yeah.
shipping deadline and you don't
Like
have
you
those
can
skills
solder,
yet, it's a
you can
nightmare.
solder up like 10 custom Arduino shields or something by hand.
But you
Yeah.
can't do
But you can't do
10,000.
1,000. You
Yeah.
can't even do 1,000 by hand, and then suddenly you're involving other people, and then it gets very complicated.
Yeah.
Yeah. Someone mentioned Tindy has a fundraising.
They do, but I
function,
think it's
too.
pretty minimal. I don't think it's not meant for like
Okay.
Kickstarter ask $100,000 to $200,000.
Next up,
type things. I mean, you might be able to. But.
can you use the our soundboard with MIDI? It's the VS1053 codec board with MIDI.
It does have MIDI capability. It's in the tutorial that we wrote and released.
We have that glove
last
tutorial,
week.
too,
And
yeah.
we did the glove tutorial. You can send it MIDI commands.
Yeah.
And we have an example also.
Oh, I could take this one. What's the estimated price of the Wi-Fi Arduino? So we're working on a CC3000, basically with an Arduino on it. We want to make it as low cost as possible.
I'm trying to hit $50.
Yeah, which is
But it's also I'm being very decisive about what gets included.
yeah.
But I think $50 is a good price, and the nice thing about that price is like it allows resellers.
Yeah.
We're also fighting with TI trying to get them to give us a better deal on the module, so all of this depends.
Yeah.
But I think $50 is a pretty
Right.
reasonable.
Someone wants to know, is there a ring compass tutorial? Some fellow posted a video, and I think he did a tutorial, so
A
check
what
that
compass?
out. Our ring, our LED ring.
Oh yeah,
using
somebody did a
compass
company.
sensors.
Yeah, I didn't do that. Somebody else did that.
Yeah.
They posted on YouTube or something. Or
Wait, you
Vine.
carry magnetic field sensors?
Yeah.
Nice.
Yeah, we have a compass accelerometer, the LSM.
Yeah, that's what you
303.
need. That's what you need to do inertial measurement.
Yeah. Next up, can you use your larger solenoid for an electronic door lock project. Is it strong enough?
You can, but if you wait, we will soon have really nice electronic solenoid lock type things in the store.
Okay.
I don't know when though, no ETA.
That
Couple
was
weeks. They're on order.
the questions. Thank you. Speed round. That was fantastic. We're going to be running just a couple minutes over, but that's okay. Reminder, the code is 4 years, 14% off everything in stock in Adafruit store. Celebrating 4 years, 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 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4.
It's kind of exciting.
So frenetic.
Yeah.
I love it.
All
It's
right.
gotta come down.
It's trivia question.
You're up here, I need you down here.
It's trivia question time. Lady Ada, what are the rules?
Rules are if you've won a trivia contest with us, you can't enter again. Only one winner per lifetime, and that's our lifetime.
Yeah.
So if you've died and been come back as a zombie, it doesn't count. Sorry. The prize today is either a CC3000 Wi-Fi shield or a Neo Matrix. It's up to you. We couldn't decide.
You pick.
You get both. Fine.
What?
Fine.
What?
Every week.
No.
What? No.
You're too nice. Come on. Come on.
Get out of here.
Every week.
You're crazy.
Every week, Lamore gets to be the good person and give extra stuff. I'm always like box of nails or, I want to be good cop.
The box
for a
of nails
change.
was a lot of control.
This time you get a used pencil.
Yeah,
You
well,
better
no, we
be
had
happy with it.
RFID nails or
you
nails
get
that
this.
have RFID.
You get this pen that I've chewed on. No. You okay? Fine. Fine.
Both,
Fine.
okay.
Fine,
Okay.
both?
You get both.
Okay.
All right, here's the.
God, you're gonna put us out of business.
Yeah, here's the trivia question. You ready? What was the date of the first Ask an Engineer?
And it
figured
wasn't
out?
today. And it wasn't.
Yeah.
It was not
Yeah,
exactly.
what was the date?
4 years ago.
Yeah,
It's
what
not
is
exactly
it?
4 years ago.
So you can
How
look on a
did-
calendar and probably guess it and figure out, but what's the date? So it'll be a little bit of a delay as people get this because it.
Gotta
takes
get
a
the
moment.
day, the date, and the year.
Yeah, and we're giving away.
You can't just say it like, oh,
Yeah.
August.
Does it have to be UTC format?
We're giving away
It
one
does
of
not
these.
have to be in Unix time
one of
format.
these.
Although,
That would be special.
yeah, you're getting twice
Yeah.
the good, so you have to be twice as good to get this prize.
Yeah.
4 years ago, ish.
Let's see who gets this. It's pretty easy.
The
'cause
good
it's
news
4
is
years
it-
ago.
You can just look at a calendar and you have 4 chances, really.
Yeah, there's only 4 Saturdays.
There's really only 4 Saturdays, so you
4 years ago, so you
so
guys
you
can figure it out.
you can just guess. What
Yeah.
you mean? Open up iCal. We'll hang out while you do that.
Yeah.
Thanks for this, Pibo.
Yeah.
Let's stick that back here.
Let's see.
Oh, pen gone.
Quick catch.
This goes back in the demo bin.
August 20th is not correct.
Can you toss this in the demo bin?
Yes, ma'am.
It's my demo bin. You touch, you die.
Start date 1, 2, 3, 4, 5 is not correct.
Good try. You guys.
8/22 is not correct. 8/13 is not correct. August 16th is not correct.
Full date.
Yeah.
You don't have to get the time.
Yeah. And this
But
is
it was
this
probably
is,
10. Was it
This
10?
is the longest it's taken anyone to answer
Okay.
one of these questions.
That's not true.
Kevin.
No, we've had it wrong.
Kevin Watkins, August 15th, 2009. Congratulations, you win both of those things.
That's fabulous. I hope you do something
Congratulations.
blinky and
Email
wireless.
support@adafruit.com, and we will send these out to you. I'm going to cut and paste. You won. Okay.
You are already a winner.
All right. So yes, you're going to get the NeoPixel 8x8 grid and the Adafruit Internet of Things.
Don't go blind. This thing will burn your
I got a
retinas.
moment like
Yeah.
like people win, everyone leaves the chat.
Bam, they'll go. Okay.
Later.
All right. So
They're not
4
going to hear
years
all the
of
cool
shows
stuff that
in
we're
the
going to
can.
say.
Well,
Yeah, you
thank
guys
you so
are
much
awesome.
for being a wonderful part of not only the show but our lives.
Well, thank you for having me.
Thank you.
Glad
and,
to be here.
Thank you all of our staff here at
More
Adafruit
beer,
that makes
some
everything
more
possible,
high five.
especially the ones who stop in for the show. Thank you, our community and customers. It's not possible to do a show without the most important thing, which is the audience.
That's
so,
right. I would not
Viewers
do
like
this
you.
if it was just like crickets.
Yeah.
That'd be sad.
And the show and tell. Thank you, everyone who
We
showed
have
up
a
on that.
pretty good thing going.
We do. And I don't know when we're going to stop doing Ask an Engineer, but I hope we can do this for our
We
entire
might do
lives.
it forever.
Yeah. Yeah, I think it's a possibility. You're always going to be doing engineering. There's no stopping
I'm
you.
not. That's like it seems to be happening.
Yeah.
I think
All
it's turning into a dangerous habit.
I know. I do too much. engineering.
All right. So
I
a
gotta
little
bring
quick
back-
photo of MOSFET. He's at home right now. He's not allowed in our factory. of course.
I'll
Ruffle
let
me
you.
out.
I'll give you a secret. I engineered before the show, and I'm probably gonna go home. I'm gonna engineer.
You're just doing
tomorrow.
engineering. Don't forget the code is 4 years. It expires in about 53 minutes or 52 minutes, so get on that right away. 14% off. I don't think we're going to do 15% off next year, so this might be the most massive
Enjoy it
code.
while you can.
We might,
Maybe.
but I don't know.
That may be.
And with that, here is your moment of Zener. Bye, everyone.